water, and my tool is clearly leveled correctly. There's no visible mirages, which means very minimal refraction, and I can see in the distance buildings of known height, and the horizontal plane created by the auto level is intersecting well above my local elevation, the top of a 15-story building, and I know the building is not at a lower elevation. What else could be going on? The tides, which in this location in Oahu, only change by an average of 2 feet on any given day throughout the year. Shoaling? Well, that only accounts for about 2 or 3 feet of additional wave height. Brian, if you look closely, the level of the water is in line with about the 8th floor in this building. That's about 80 feet of the building hidden by the water, which is almost exactly what's predicted by the Earth Curve calculator.
Okay, I'm going to play this again, so pay attention.
Level is intersecting well above my local elevation, the top of a 15-story building, and I know the level of the water is in line with about the 8th floor in this building. That's
so the 8th floor and the 15th floor, okay? Then he has a line between the water and the crosshairs of 11.3 feet. Maybe that's why we don't shoot over them distances, B-ball. So does 7 stories equal 11.3 feet? And how come you only have just like 5, maybe 5.5 showing there when you just said 7? So you say the Earth Curve calculator predicts it. So 1.22 times the square root of 11, that's your observer's height in feet, gives us about 4 miles. So that's about 10.5 feet of drop, B-ball. 10.5 feet of drop represents between the water and the 15th floor.
About 80 feet of the building hidden by the water, which is almost exactly what's predicted by the Earth Curve calculator. And don't you remember having this conversation before, when you asked me to go to the same location later on in the day?
Is that what I challenged you to do, B-ball? To go later on in the day? Is that honest? Because I've already presented the evidence for this, and now you're doubling, really tripling down. Is that honest, B-ball?
Which I did. And you claimed that I would be able to see more of the building, which I couldn't.
Why would I challenge you to go later in the day when the sun's had more time to heat up the water and everything else? Okay? You know what I challenged you. In fact, I'll play the evidence of our discussion.
Then after asking me to go to the same location at a later time in the day, you turned around and said it was the wrong time of the day? And then your best rebuttal was to call me a liar in a video?
Yeah, let me change that though. A bold-faced liar. You know I challenge you to go at night, but allow me to present the evidence.
It seems to me that Brian, as well as most flat earthers, don't really care about evidence at this point.
Go when there's no way.
How many times do I have to go? You tell me.
Once. Go when
I've filmed it 8 times, but I've gone many more times.
Okay, go one time, like I'm telling you to. Go after the sunset. Go after the sunsets, and go on a day that's where the seeds are, where the surf's only a couple feet. Try it. See what you see.
What do you mean? Okay. Check this out. I'm gonna make a prediction, right? I'm gonna do this for you, right? And I'm gonna go there in the evening, and then I'm gonna show you that I'm not gonna see. It's gonna be exactly the same, right? Okay. I promise.
Nighttime's the best time, people. It's when I don't know.
Everyone that's listening right now, I promise you, I will make this video.
So everyone listening, I promise I will make this video, and no stuttering. So he at least had the right intentions there. But wait till he says he's gonna go at night. Like, I'm wondering, looking back, did he ever have any true intentions of going at night?
I guarantee when I go and film this when the sun is probably about to go down, and I'm gonna go
after the sun goes down. As the sun goes down, or after. So our whole conversation was go at night. I made it crystal clear. Told him after sunset and after the sun goes down at night. So who's dishonest?
See, I guarantee you're gonna make some sort of other excuse for what's going on, because it's
now. Let me tell y'all what's really gonna happen. We're never gonna see this video, because when he goes and sees it, he's gonna fucking come up with an excuse in his head and not post the video.
I'm gonna do it.
We're gonna see. So my prediction came true. He never posted a video, or this is what he tried to claim a few days later. This is supposed to be calm conditions, no waves, and at night.
I went back to that same observation point, and what Brian said was that I would see a lot more if I went later on in the day. Now I wasn't able to go after sunset.
I said
hold on, Brian. You said later on in the day. I couldn't go after sunset because I'm busy. I have a family and stuff. So I went.
I couldn't go because I'm a bit busy. I have a family.
It's like 30 minutes before I'm sorry, maybe about an hour before sunset. So
So he admitted, where I just pulled, where he said later in the day, he admitted in that video that I did say night. But now he's tripling down. This guy's a bold-faced liar, and if he wants to call me out, I'll go back and pull it and prove it.
Without providing evidence of how incorrect it is, can you say intellectually dishonest?
On the 5th or 6th or even higher floor.
Let's see who's intellectually dishonest, okay, and who's just making shit up or doesn't understand the topic.
This is something that you can measure.
The process of leveling has not changed in well over 150 years. It is
Leveling. Hear that? The process of leveling, meaning elevations. Okay?
still a terrestrial measurement system that has limited sight differential. And particularly in geodetic leveling, about the farthest you can go is going to be about 50 meters. So you can't make observations 100 meters or 200 or 300 meters.
So you heard the professional say that the longest you can go is about 50 meters. Me personally, I don't like to go much over 50 feet, but 50 meters, he said you can't go 200 or 300 meters, but Bob thinks you can go 12 miles.
Now, Brian, you wouldn't be trying to cherry pick now, would you? Let's just see what else that professional had to say.
Yeah, watch him skip. He thinks he's slick, but he's not. It's bad to be dumb and dishonest because you get caught doing shit like this. Now here he's going to show the end of the clip that I played, and then he's going to switch over to horizontal triangles. What Bob was showing and what you're showing is elevation, leveling. Okay, you being slick, bud. We all see it.
20s or 30s. Here you see the pictures of the coast surveyors out with the old optical level, actually a Fisher level, and you've got two rodmen out. Well, the same process is true today, although increasingly we're seeing the use of digital leveling so that the observer themselves do not have to read the rods. The instrument is reading the rod.
Here's the end of my clip. I mean, and then now he switches over to horizontal triangles, not leveling. Okay, and tells me I'm cherry picking. Either he's cherry picking or he's lying. I think we all know what's going on.
Surveyor would go out, you'd have three surveyors. They would measure the angles of this triangle, and realizing that a triangle, the angles of a triangle have to amount to 180 degrees. Mind you, there's curvature of the earth, and so we're really dealing with slightly different math, but
So it's a different math. So if I invoke an orientation change and use different math, then I get spherical excess.
let's just, take it as simple as possible for the moment. If I know these angles, then I know the three angles of the triangle. But these are long distances. They might be 10, 15, 20, in some areas, 40, 50, 60, 80, 100 miles. How am I going to measure that? I need to have at least one distance that I know. So before the advent of GPS, they would take a lot of time to actually measure the distance between two of those points. It's referred to as a baseline. Today,
That's not a baseline for elevation, B-ball. That's a baseline to calculate their horizontal distances.
in GPS GNSS, we refer to as a baseline as the vector between 2 points. Well, this is very similar. It's the measured distance between 2 points. So they would go out and they would measure a distance here, and then somewhere else in this network they would have another measurement. And if I know this distance, and I know...
He's literally just proving my point on other videos. See how they only measure baselines here and there. They just do all calculations. That guy just admitted that it's different math because the triangles give 180 degrees. So he's literally, he doesn't understand any of this, man.
the angles, I can then, through the law of sines, I can compute the distances along these other lines. And
I've told other people in arguing, like Zanuck and Ruhif and all them, they're using spherical mathematics and computing the distance. They're not measuring spherical excess. They're calculating it. And that starts with the distances.
so on, and so on, and so on. And if I happen to know the coordinates of this point, and its orientation, or its azimuth.
Orientation. That's what I showed them, and B-Ball's about to show this next. I had to literally get a globe and put toothpicks on it to show them that the angles added up to 180 degrees with line of sight until you induce an orientation change, which is what is in debate. That's what's in question, is whether the orientation's changing or if it's flat. So it's all assumed. They don't measure spherical excess. So thanks, B-Ball, for showing all this.
And I now know the angular difference to this point, and the distance, I can now compute the coordinates of that point.
And lastly, Brian is trying to claim that geodetic surveyors haven't measured spherical excess because the observations were line of sight. Oh, Brian, when will you ever learn?
Oh, Brian, when will you ever learn? Listen to this dunce. Oh, Brian. If you understood any of this, you wouldn't have played any of that clip, bro.
What you're missing here is that the distance measured is not a chord through the sky. It's measured along the surface of the earth.
You just heard the guy, B-Ball. About every 20 triangles, they're measuring one line on the ground and calculating the rest. They're measuring angles in this survey, B-Ball. Angles. Clear you don't understand it, but they are measuring the angles and transferring them to the ground and inducing an orientation change. You heard them.
When this
No, it's not. It is line of sight. They often had to build towers 80, 100 or more feet to ensure line of sight. It is a chord through the air. Then it's transferred mathematically and calculated to the ground. It's transferred to the ground, okay? Based off of line of sight. And anytime you have line of sight, you have 180, B-Ball. It doesn't even matter. Even on a globe, I showed that even on a globe, it's 180 if you got line of sight. It's 3 coplanar points. No matter how high one side is or lower the other side is. But
team of surveyors measured distances in 1916, it was done using a long metal tape, which is laid along the ground, not pulled taut between 2 control points, which is what you're suggesting here.
they can only measure one angle from each point, B-Ball, to the other two. They can only measure the angle between the other two stations. Okay? It's when they combine them and induce an orientation change that they get the excess, bro. Go study this shit.
I know you really and truly want the earth to be flat, but strawmanning the actual process of measuring.
Now I want the earth to be flat. This whole video has been horse shit, lies, and straw man with arrogance.
Once again, thanks for watching.